years, our astronauts were all young men, fighter and test pilots. Well, not anymore. Shannon Lucid is 53 with a doctorate in biochemistry. When she returned to Earth last month, she'd set an American space endurance record, 188 days aboard the Russian space station Mir. Her mission was to conduct medical and physiological experiments on humans living in zero gravity. Results of these space longevity tests are key in learning just how long humans can stay in space and how to stay healthy there. And joining us by telephone now, doctor and astronaut Dr. Bernard Harris. And he is not just an observer. 2 shuttle missions to his credit, 438 hours in space, and he walked. That's a funny way of saying it, but he did an EVA, extravehicular activity, out there in his spacesuit. He has been there. Dr. Harris, hi.
Good evening, David.
Doctor, what can you tell us? I know that you have retired from NASA, but what can you tell us about Shannon Lucid's condition when she came down from the 6 months of weightlessness?
Well, I can't tell you anything specifically about her because I did not follow her case per se, but I can give you an idea by my experience. We know from the work that we've done in the early program and also in the shuttle program that, for example, we lose about 1% of bone a month. Shannon spent 6 months up there. So one could theorize that she lost about 6% of her bone, in addition to muscle changes, atrophy, and also changes in her cardiovascular system or her heart system.
How realistic is it? I mean, we've been sitting here talking about human beings going to Mars, and assuming that it's a 6-month trip out, a 6-month trip back, but spending anywhere from a year and a half to 2 or 3 years on the surface of Mars, how realistic is it to think that physiologically a human being would be capable of doing that, given what we know now about medicine and taking care of ourselves in space?
Well, as you know, we're still in the process of learning a lot, and the mission in which Shannon just completed, in addition to the missions that we did in the shuttle, and also the Russians who have a lot of experience in long-duration flight, has kind of given us an idea of what to look out for. And right at the top of the list is bone turnover, the loss of bone, and the consequences of dumping large amounts of calcium into our blood system. Development of kidney stones, development of calcium in other spots. In addition, just the sheer loss in muscle performance and strength puts into question, if we don't have countermeasures on the way to Mars, of even being able to walk on the surface. So there are a lot of issues out there, and I think that we'll be able to overcome them for this mission.
How realistic is it to think that by the year, say, 2008 or 2010, we'll be able to solve those problems?
I think they're pretty realistic. We have the International Station that will be going up in a few years. We'll have an opportunity to have an orbiting laboratory up for 7 days a week, 365 days a year, and we'll get a lot of answers to these questions. And let me say this. In terms of all of the changes that we know of, the major changes that would impact us for a trip to Mars, exercise as a countermeasure seems to help in many ways. It helps to maintain calcium, helps to maintain muscle mass, it builds up the heart. So you can bet there's going to be a strict regime of exercise on the way to Mars.
Dr. Harris, thank you for being with us tonight.
Thank you.
And we have a phone call from Kim in New York. Kim?
David, it's Jim.
Jim, I'm sorry. Jim, hi.
Hi, David. My question is for really any of your guests, and it really is sort of long range. Who should or who will own any resources or discoveries made on Mars or other planets? And is there anything in the works in regard to international agreements?
I can take that one partly. We already have in place international agreements about the science information. The science information belongs to the world. And as a matter of fact, when we have our 2 missions at Mars next year, as soon as we get information, it's going on to the internet. It'll be on the World Wide Web, available to everybody. As far as owning resources, I don't think that's going to be a big issue, because I think, frankly, the only way we're going to be able to do these things is internationally. And it's like, well, Buzz and Jack can talk about the moon.
Well, I'm not sure that it has to be an international governmental effort. It may be an international private sector effort. But right now, the status of space law is that it's permissive. The Space Act of 1966, or the Space Treaty, Outer Space Treaty of 1966, pretty much left it permissive. It's not unlike the situation that we deal with in our public lands, where you can extract a resource and own the resource, but you can't own the land.
Buzz, how important is international cooperation that Donna mentioned, Jack has mentioned, that we all have to do this together if we're going to get it done?
International cooperation doesn't always make it cheaper. A lot of times it's a lot more expensive to bring all these people together. But I think from an overall standpoint, one nation is just not going to be able to mount a mission to Mars. It's going to have to be a joint thing.
How is that, Valerie? What's going to happen? Who has to do what to create a kind of process that's going to lead to this becoming a reality and not just being a conversation?
I think that in addition to the technological challenges and the political process, we're probably going to need to create a metaphor for the venture, as we had in the 1960s, the very strong metaphor of pioneering the frontier of space. And that metaphor worked in the 1960s when we were venturing out into an area where we hadn't gone before. It hasn't been as compelling an image while we've been in Earth orbit, because we're in familiar territory. That metaphor could work again for missions to Mars. It was a metaphor that I think appealed to the public as well as to the politicians and the administrators, because it captured this sense that we have of ourselves as a nation of explorers. It captured our sense of having a pioneering heritage. There was romance, there was adventure, there was idealism and optimism, a sense of risk and challenge, but of an opportunity to succeed.
Who has to lead the way? Who has to lead the way to create this kind of leadership to get that kind of reaction?
Yeah, well, let me just say this. We've got a decision point coming up right now with this Space Summit. This Space Summit was called not just to address the general question of the NASA budget, although that's very important. It was called by President Clinton directly after this discovery of evidence of life in the Martian rocks. And we have a chance right now to actually get a Humans to Mars program initiated, to actually expand the program from simply robots to something that goes a lot deeper with actual human explorers. And if people who are listening to this show want to make this happen, want to have a space program that is pioneering new worlds again, what they need to do is let President Gore and tell him, I want a Humans to Mars program. I want to go beyond doing, Earth to orbit missions over and over and over again. I think that our space program should be opening up new worlds. I want a space program that's going to inspire my kids.
I think we have to be careful. We sit back and always anticipate that government's going to lead this. There well may be the private sector as the leader for this kind of an initiative.
How realistic is it to think that the private sector could do it faster and perhaps better and/or more inexpensively than government?
I think it's highly realistic, particularly where there are resources of value involved, and particularly the fusion or solar energy resources that can be obtained on the moon can be utilized here on Earth, not only as a more efficient way of producing energy, but also to protect the global environment as an alternative to fossil fuels. So there is a private sector potential initiative there that could enable everything else.
All right, excuse me, Dr. Zubrin, we've got to go. But we'll be back. We're not leaving. Is science fiction becoming science fact? Another aspect to all of this. And we'll be back with Dr. Zubrin, among others.